Hello all, a very warm welcome. Today we are looking at a LeetCode question 1379. Uh, this is also being asked in week 1, January 1st week of 2021, day 2. The title of the question says find the corresponding node of a binary tree in a clone of that tree. Okay, so we have to find a node in the binary tree in the clone of that tree. Okay, not too sure whether that is uh, that clear, but let's look at the description of it. So given two binary trees, original and clone, and given a reference to a node in the original tree, a clone tree is a copy of the original tree. Return a reference of the same node in the clone tree. Okay, so this is what it says. So if I have a tree original, say assuming say this is the original tree, and I'm also given a target. I'm given a target of say 3. So what we have to do is we have to search for this target in the original tree, and once we find that target in the original tree, we have to return the same positioned node from the clone tree. So in order to search, either we can use the depth first search or the breadth first search. And in depth first search, so we can go for either in order, post order, pre-order traversal. So let's do a pre-order traversal. So if I'm looking at a node target 3, so what we have to do is whenever we are iterating through and whatever operation we are doing with the original tree, we have to do the same for the clone tree as well. So looking at the pre-order traversal, so 3 is not equal to 7, which is like root left right. So 3 is not equal to 7, cool. Then I'll go to the next node, 4. 4 is not equal to 3, okay. Then there's no node afterward. Then I'll go back, I'll go towards the right part of it, which is 3. Here's the match. So as I said, whatever operation we are going to do with the original node, we have to do the same for the cloned node as well. So assuming the same happened for this node as well, my position would have been at that time at the same place at the both places. The moment I see a match in the original tree, I'll have to return the same position clone tree, same node from the clone tree as well, from the same position, right? So for example here 7 7, this was pretty straightforward. Let's look at this one. So here I have this original tree and I'm given a target variable of 5. So what we'll do is 5 not equal to 1, cool. I'll go to the left part of it. Same I'll go with the clone as well. I'll go to the left part of it. 5 not equal to 2, cool. I'll go to the left part. 5 not equal to 4, I'll go to the left part. 5 not equal to 8, cool. There's no match. Right now I'm at 8th position in the both the places, in the cloned and in the original as well. After that there's nothing. After that there's null. So I'll go back. I'll go to 4. I'll see whether there's anything on the right. Right, I have 9. So 9 is not equal to 5. Okay, I'll go back. I'll go to 2 now. I'll go to 5 now. 5 is a match. The moment I found a match, instead of returning this node, I'll have to return this node, the reference node of the cloned tree. Okay, so what we are going to do is we are going to use a pre-order traversal. So let's look at the constraints. All the things are unique, and target node is a node from the original tree and is not null. Okay, cool. So the important point to note is we are not interested in looking at the values, because what we are looking at is the reference part of it. So uh, that's the advantage which we are having right now. So uh, when you're doing a pre-order traversal, because that means we have to do a recursion here, and we have to call the same method again with the next node. So if I look at boundary condition, if my tree is null, if my node is null, then I'll just return null. So this is my boundary condition. If my say original is double equal to target, then I have to return cloned. That's what the question says, that if I find a match, I need to return the reference of the cloned variable. Now if nothing happens, if I don't find a match, and if it is null, if it is not null, then I'll go towards the left node. So get target copy original dot left. I'll perform the same operation to the cloned as well, and I'll pass the target variable. Now, if everything happened and I have found a match, that is the only condition wherein I'll have this node being not nullable. That means I have found a match. So I'll just return this. If there was no match, that means I have returned a null. That means I have to go towards the go and search for the right part of it. Okay, get target copy. Same for the clone tree, and same condition here. So if I have found a match, then only it will be a not null value. Otherwise, if nothing happened, then a null. That means with all the pre-order, post-order traversals, I didn't find a match, and hence I am going to return null. So let's see, run the code and see what happens. Oh, okay. So I think I misspelled the original. Okay, so original. Okay, let's run now. Cool, that passed on the test case. Let's try to submit it. I accept it. Cool, nice. So let's look at the complexity of it. Complexity of it will be O of n again, wherein n will be the number of nodes in the binary tree, because in the worst case scenario, when we are looking at a target, we have to look at each and every node of that particular binary tree. So this is it. Thanks, guys. If you have any comments, please shoot it. Hope you enjoyed the video. Thank you. Thanks a lot.